Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method part 3. So we are going to use another method to solve the given differential equation using variation of parameters. So let's get going. Problem solve y double dash plus 2y dash plus y equal to e power minus x log x or d square plus 2d plus 1 into y equal to e power minus x log x using variation of parameters method. So we are given a differential equation of order 2. See, both the equations are same. This is in operator form. Okay. The first equation in operator form is d square plus 2d plus 1 into y equal to e power minus x log x. So let's see. Given differential equation, y double dash plus 2y dash plus y equal to e power minus x log x. Consider as equation number 1. We can write y double dash as d square y by dx square plus 2 into dy by dx plus y equal to e power minus x log x, right? We can write d square y by dx square as d square y plus 2 into dy plus y equal to e power minus x log x. Let's now take y common from all the three terms of LHS. We'll get d square plus 2d plus 1 into y equal to e power minus x log x. Consider as equation number 2, which is in operator form. So f of d into y equal to r of x, where f of d equal to d square plus 2d plus 1 and r of x is e power minus x log x. Now the solution to this equation of equation 1 is given by y equal to yc plus yp. So we'll find yc using the auxiliary equation and later using yc we'll find yp. Okay. The general solution of equation 1 and 2 is given by y equal to yc plus yp. Now let's see the auxiliary equation to find complementary function. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 2d plus 1, right? Let's replace differential operator by m, so that we'll get f of m equal to m square plus 2m plus 1. Now the auxiliary equation becomes m square plus 2m plus 1 equal to 0, or it is an expansion of m plus 1 whole square, or we can write it as m square plus 2 into m into 1 plus write 1 as 1 square equals to 0, which is an expansion of m plus 1 whole square. So we'll get m plus 1 whole square equal to 0, or we can write it as m plus 1 into m plus 1 equal to 0. Now we equate each factor to 0. If m plus 1 equal to 0, we'll get m equal to minus 1. So from this we'll get m equal to minus 1, which are repeated roots. The roots are real and equal. We know that when two roots are real and equal, say m1 equal to m2, then the complementary function looks like c1 plus c2x into e power that equal root into x, right? Now coming to our complementary function. yc equals to c1 plus c2x into e power equal root minus 1 into x. This gives us c1 plus c2x into e power minus x, or c1 e power minus x plus c2x e power minus x. Okay, therefore yc equal to c1 plus c2x into e power minus x, or yc equal to c1 e power minus x plus c2x e power minus x. For time being, I'll take the second one. Now just replace the parameters with functions of x, a and b to get yp. let yp equal to, just replace the constants or parameters with functions of x, a and b. Will get yp equal to a e power minus x plus bx e power minus x, where a and b are functions of x. Now we can compare yp with au plus bv or yc with c1u plus c2v, so that we will get u and v, where u is e power minus x and v is x e power minus x. See, v is x e power minus x and u is e power minus x, where u is e power minus x and v is x e power minus x. Now we'll find a and b using a equal to integral minus v into r of x by u v1 minus vu1 into dx, and b is given by integral u into r of x by u v1 minus vu1 into dx. So here if you notice, we are having u v1 minus vu1 in both the formulas. So let's begin with u v1 minus vu1 and later we will find a, b, yp and finally the general solution. v1 is nothing but derivative of v with respect to x, minus v into u1 is nothing but derivative of u with respect to x, is equals to u e power minus x into derivative of v x e power minus x minus v into derivative of u with respect to x. This gives us e power minus x of derivative of u into v is, we have uv whole dash equals to u dash v plus v dash u, right? We are going to apply this formula to find derivative of x e power minus x. So you'll get derivative of x with respect to x with into e power minus x plus derivative of e power minus x into x minus x into e power minus x into derivative of e power minus x with respect to x is minus e power minus x, which is equals to e power minus x of derivative of x with respect to x is 1 into e power minus x plus derivative of e power minus x with respect to x is minus e power minus x into x minus into minus plus x e power minus x into e power minus x. This gives us e power minus x of e power minus x minus x e power minus x plus x into e power minus x e power minus x, which is equals to e power minus x into e power minus x minus x into e power minus x e power minus x plus x into e power minus x e power minus x, right? We have e power minus x into e power minus x. We can write this as e power minus x, which is equals to e power minus 2x. Now replace e power minus x into e power minus x with e power minus 2x, and we'll get e power minus 2x minus x e power minus 2x plus x e power minus 2x. So here minus e power minus 2x and plus e power minus plus x e power minus 2x gets cancelled and we'll get e power minus 2x. Therefore u v1 minus vu1 equal to e power minus 2x, right? Let's now find a, b and yp. A is given by integral minus v into r of x by u v1 minus vu1 into dx, right? This is equals to integral minus v is x e power minus x into r of x e power minus x log x by u v1 minus v1 is e power minus 2x into dx. This gives us minus integral x into e power minus x e power minus x into log x by e power minus 2x dx. So here in the numerator we are having e power minus x into e power minus 2x. We know that e power minus x into e power minus x can be written as e power minus 2x, right? Let's replace e power minus x into e power minus x by e power minus 2x into log x by e power minus 2x dx. So here e power minus 2x gets cancelled and you'll get minus x log x dx. Let's evaluate integral x log x dx using integration by parts formula. We can write integral x log x dx as log x into x dx. The integrand is of product of logarithmic function and polynomial function. So consider the logarithmic function as u and the remaining part as dv and apply integration by parts formula. Integral u dv equal to uv minus integral v du. Okay, we have u equal to log x and dv equal to x dx. So here differentiate on both sides with respect to x. We'll get du by dx equal to derivative of log x with respect to x is 1 by x. From this we'll get du equal to 1 by x dx. Right? Now integrate on both sides to find v. We'll get v equal to x square by 2. Now apply this formula. We'll get integral u dv log x into x dx, which is x log x dx equal to u into v log x into x square by 2, which is x square log x by 2 minus integral v x square by 2 into du. Du is 1 by x dx. Here 1x gets cancelled and we'll get x square log x by 2 minus 1 by 2 into integral x dx. This is equals to x square log x by 2 minus 1 by 2 into x square by 2 plus integral constant is sum c. Okay, now since integral x log x dx equals to x square log x by 2 here, x square log x by 2 minus x square by 2 2s are 4, x square by 4, then a becomes minus of integral x log x dx is x square log x by 2 minus x square by 4, which gives us a equal to minus x square log x by 2 minus into minus plus x square by 4. Therefore a equal to minus x square log x by 2 plus x square by 4. We got a. Let's now find b. B is given by integral u into r of x by uv1 minus vu1 into dx. U is e power minus x into r of x is e power minus x log x by uv1 minus v1 is e power minus 2x into dx is equals to integral e power minus x into log x by e power minus 2x into dx. We can replace e power minus x into e power minus x with e power minus 2x, since e power minus x into e power minus x can be written as e power minus x, which is equals to e power minus 2x, right? Then we'll get integral e power minus 2x log x by e power minus 2x dx, where e power minus 2x gets cancelled, we'll get integral log x dx. Since we know that integral log x dx is x log x minus x, so we'll get x log x minus x. Therefore b equal to x log x minus x. See, if you forget the formula integral log x dx, you can find it using integration by parts formula. Let me show you that. We can write log x dx as log x into 1 into dx. So the integrand is of product of logarithmic function to constant polynomial function, right? We can consider the logarithmic function as u and the remaining part as dv. Okay, we can apply integral u dv equal to uv minus integral v du, where u equal to log x and dv equal to 1 dx or simply dx. Now differentiate on both sides with respect to x. We'll get du by dx equals to derivative of log x with respect to x is 1 by x. From this we'll get du equal to 1 by x dx, right? And here we'll integrate on both sides, then we'll get v equal to x. Now applying this formula, we'll have integral u dv, u into dv, that is log x into 1 dx is log x dx equal to uv log x into x log x minus integral v into du is 1 by x dx, where x gets cancelled and we'll get x log x minus integral 1 into dx is dx, integral dx is x, which is log x minus x. Okay. Yp is given by a e power minus x plus bx e power minus x, right? Is equals to a minus x square log x by 2 plus x square by 4 into e power minus x plus b x log x minus x into x e power minus x. We'll get minus x square e power minus x log x by 2 plus x square e power minus x by 4 plus x square e power minus x log x minus x square e power minus x. Now take x square e power minus x log x from these two terms. We'll get x square e power minus x log x of minus 1 by 2 plus 1, and take x square e power minus x common from these two terms. We'll get plus x square e power minus x of 1 by 4 minus 1 is equals to x square e power minus x log x of minus 1 by 2 plus 1, or 1 minus half is half plus x square e power minus x into 1 by 4 minus 1 is minus 3 by 4, right, which is equals to 1 by 2 x square e power minus x log x minus 3 by 4 x square e power minus x, which is our required yp. Or you can take 1 by 2 x square e power minus x common from these two terms. Let's see that also. I'll just write minus 3 by 4 as 3 by 2 into 1 by 2 for my convenience. From this we'll get yp equal to, take 1 by 2 x square e power minus x common from these two terms. We'll get 1 by 2 x square e power minus x of log x minus 3 by 2. Okay. Either you can write yp equal to 1 by 2 x square e power minus x log x minus 3 by 4 x square e power minus x, or 1 by 2 x square e power x of log x minus 3 by 2. Therefore yp is equals to 1 by 2 x square e power minus x log x minus 3 by 4 x square e power minus x, or yp equal to 1 by 2 x square e power minus x of log x minus 3 by 2. Okay, now let's write the general solution. Therefore the general solution is given by y equal to yc plus yp, then y equal to yc c1 plus c2x of e power minus x plus yp. I'll write the first one. Or y equal to c1 plus c2x e power minus x plus, write the second one. Right? Which completes the problem. So this is all for now. I hope you'll understand. We'll see you in the next video. Until then, bye bye.